Aligning Policy, Practice and Market Readiness, which will be presented by Aoife Foley. Can I just remind everybody that this session will be recorded, and to make sure that you have your microphones muted and your cameras off. Aoife will be presenting for about 45 minutes, and then we will be moving. There'll be an opportunity to ask some questions. If you can please put your questions into the chat, and then we'll move on to those after the presentation. Aoife, I'm going to stop sharing this now, and if you want to share your presentation.
Can you see that?
I can, yes.
Perfect. Just 2 seconds now. I've done something a bit silly. Stop sharing. There we go. So the first thing I'd like to do this morning is thank Sophia, Natalie, Shan, Sarah, David, and Dilzar basically for supporting me in all my work over the last few weeks and months. This presentation really is going to look at policy, practice and market readiness. And when I mean market, I mean both the market for production and the market for along the whole supply chain in terms of uptake by industry and society at large. The presentation is based on a paper that's been led by Dilzar with input from Benoit, Zoya, Clara, Joseph, David and Sarah. And it's on certificate standards and regulatory framework for hydrogen, and it's a review paper. So we've heard now over the last, I suppose it's 10 years now, really started in 2015, that hydrogen was going to be pivotal in achieving net zero goals. But we've seen a significant lag due to fragmented regulation, market misalignment and inconsistent standards. Now, that's nothing new in any new technology or sector. And it's the same in transport electrification. It was the same when we moved, you know, if you look at any technology, from records to CDs, the mini disc, VHF and BASF, what we see is that a lot of technologies, they take a few years to embed into society, particularly where there's a lot of different groupings, individuals and countries involved, regulatory organisations, standards organisations, professional bodies, different OEMs. It's nothing new. And I always say to my students when I'm teaching, you know, when somebody tells you hydrogen is going to be here in 3 or 5 years, or back in 2011 when somebody said to me electric vehicles will be hugely proliferated by 2015, take it with a pinch of salt. Really, the core of the argument, and for this presentation, is that hydrogen integration into society is going to really depend on the legitimacy of different sovereign states and different regions and what they're saying, the scalability of it. And this is what we're looking at, hydrogen and its design and how we can fit it into the energy transition. Now, I think somebody's microphone is on. Yeah, it's Garrett's. I'll just mute you, Garrett, there. So in terms of where we're at the moment, okay, you know, we've only reached, we talk about 20 gigawatts of, we've reached 20 gigawatts of electrolyzers, and we want to reach nearly 1,000 gigawatts. And that was from an IEA Aurora report in 2024. In terms of the need for hydrogen, we're talking about 560 gigawatts by 2030. We're nowhere near that. And it will be difficult to reach those targets But we set targets. It's not for us to get despondent. It's to get us to achieve something, and for us to strive and to get ourselves organised. Targets are like exams. You're never going to have everything done when you go into an exam when you're going to study. So you can see there's a huge amount of different policies around the world, and hydrogen is seen to have a role in hard to abate sectors. So hard to abate sectors are the industry, so a sector like steel making, ammonia, transport, seasonal storage in energy where you've lots of wind. And like, I mean, my first project looking at electrolyzers was in County Donegal, and it was back in 1998, 1999, and that was funded by the EU. So we Fit for 55 for Europe. We have the UK hydrogen strategy. You can see this is I borrowed from the Asian Development Institute, the Development Bank. They pulled together a report on Asia and the Pacific region and their strategies, and then we have the US National Clean Hydrogen Strategy. So lots of different strategies, and they all sort of focus on 2030. So where are we at the moment? 40 countries have strategies. It's very similar. You could almost map it identically to transport electrification back in about 2010, 2011. There is a misalignment of targets and enabling frameworks, and also in the supply chains, which again is similar to transport electrification. Policy is fragmented. Where do we currently use hydrogen? So we use it in ammonia production, oil refining, methanol production. And if you look at the amount of tons of hydrogen we produce currently, you know, we're probably talking about getting up into the 600 million tons of hydrogen. We're now in and about 100, so we're well off. The problems around the world, so if we take the UK, unclear CFD integration for low carbon hydrogen, EU, there's a delay on the renewable fuels for non-biological origin. So they're fuels that come from mostly electrification, fuels from e-fuels, you would call them. So green hydrogen and e-methanol. And in Asia, what's happening is, like us in Europe and in North America, there was a dash for coal in sort of the late 90s, early noughties. Gas generation, it was seen as lower carbon than coal. So now in Asia, they're moving to gas from coal. But the problem in Asia is that they have a lot of new coal plants, and it'll be quite expensive for a number of states to carry that burden to move from coal to gas and then onto other renewables. So what happens when policy speed outruns regulatory design? Well, I suppose if we see it, people get despondent. Again, I draw a parallel to transport electrification. People complain about no infrastructure. So Whitby would be an example where there's panic. People will talk about in transport electrification, no infrastructure, poor warranties, issues with batteries, just getting the whole of the supply chain. And when I mean the whole of the supply chain, I mean consumers, users, manufacturers, installers, commissioners, everybody along the supply chain. So in terms of national and international policy, we can see it's quite fragmented in the UK. It's quite regional. So that's because of the different setups, governance setup. So we've Scotland, they're slightly, or they would be appear to have a lot of ambitions and have invested a lot in it. We've East Midlands and Humber, that's one area. Wales is slower behind. It's all set around the cluster in Milford Haven. And then Northern Ireland, it's a few pilot projects. So in the UK, hydrogen policy coherence is elusive, despite ambitious targets. In the US, what they have is they have the Inflation Reduction Act, and $3 per kg of hydrogen gives you a tax credit. So if you look at maybe the prices that are quoted for renewable hydrogen from anywhere to $5 to $8 to $10 per kg, that's a nice a nice bottom line to include as a buffer in your cash flow if you were setting up and developing a project. In the EU, we've RED 3. That's the delay here. And how that evolves now over the next few months and weeks and years will be difficult to see. What happens with Ukraine and Russia and the price of natural gas will also play a big part here. Japan, Korea, hydrogen roadmaps, China scaling blue and green hydrogen. Strategies in Australia, Chile, and South Africa and other countries is to export hydrogen. How viable that is in the longer term and how expensive it is remains to be seen. There is a convergence in terms of policy and goals and regulatory standards, but again, very hard to see where we're going. Hydrogen, as I said already, is going to support hard to electrify sectors, so heavy industry, shipping, aviation. I likely say aviation. I think the jury is out on that, and long haul transport. There are plenty of barriers, just like transport electrification. So the infrastructure, the fragmented regulation and the costs, they vary by country to country, and even how we compare them. And I'm going to come on to that in a minute in terms of well to gate, cradle to gate. So these are life cycle analysis terminologies. So it's like comparing apples and pears. So hydrogen's fit in the energy transition. This is it, sort of. I put this table together. If anybody wants to borrow it, feel free. So you can see in terms of storage, geological storage and salt caverns. Again, that comes under pressure. And I'm using the word sort of tongue in cheek. Yeah, storing hydrogen in salt caverns is a challenge to underwrite and insure it. That's always been the issue. Again, we have the Netherlands Hooistock, Germany's cavern projects. They're all big, large projects, but the underwriting in the insurance, they would be seen as high risk. So the capex will be high, and then the interest rates on the projects for the return of investment will be difficult to get that payback period. And that's what's stalling. If you compare now to transport electrification, that is less of a challenge in comparison to hydrogen. So then regulatory approaches and emissions thresholds, you can see they are quite varied across the world. You can see carbon intensity benchmarking here. It can vary from 1.3 up to nearly 20, which is quite a variation. The EU certified high is 3.4 kgs of CO2 equivalent. You look at the UK, it's 2.4, US is less than 3, and the global hydrogen standard is less than 1. So this convergence of threshold, but to me, it's not really a convergence. It's going to have to be a mutual recognition. I think we need a transition period where we have to accept for a period of time what other countries, other regions, other standards and regulatory bodies are recommending while we all transition to a more global standard. Now, oh, there we go. So this diagram here, this figure was prepared by Dilzar. It's very, very busy, but basically what it shows you is there's a convolution of certification schemes. It's the same as carbon certification. A number of self-appointed bodies in the case of carbon certification, agencies, entities, consultancy firms have set themselves up. These are more linked in the case of hydrogen to respected, understood long-term bodies that are in existence. You can see the German Standards Organization here, very well respected, very well known. The Department of Energy in the US, but obviously they've come under staffing pressures at the moment due to Trump's layoffs. So we can see different agencies and bodies around the world. So it's quite busy. So it's really, really important that we do have a mutual recognition. Again, oh, sorry, I keep on scrolling the wrong way. In terms of market readiness, this very interesting graph shows you the variation. So in terms of biomass, hydrogen stream, all the different technologies and what you can get out of them. So it shows the technology and grid dependencies. So your emissions are really dependent on what goes on in your own grid in terms of blue, green, grey hydrogen. So that really feeds in then to that equivalence in terms of hydrogen production. The system boundaries. So the system boundaries tie into your production route and where you make your start. So is it the cradle? So the cradle is where the hydrogen starts. So if it's a crop, if it's electricity, if it's from wind, where it actually starts and where it ends up. So if it's going into transport, we talk about the wheel. If it's going into a tank to be used in a process, say ammonia production, if it's a point takeoff in electricity generation, these are all the differences, and it's just part of the story. Again, this is more of the same from the paper. And what's interesting here is that you can see we vary from around 3.5 up to 10.5. So that's a variance of about 5 kgs of CO2 equivalent per kg of hydrogen produced. But actually, that's quite narrow. So if we went back and we looked at transport electrification and something as simple as the charging plug and socket, that was more convoluted. This is narrower and I think easier to harmonise ultimately. So in terms of infrastructure and market gaps, I borrowed a graphic here from the German standards organisation on their value chain. And you can see, you know, it's so convoluted, the hydrogen pipeline network, how much are the costs going to be for that? The skilled labour, how do we move people into the hydrogen sector? It's not as simple as moving people from natural gas or from the petroleum industry into hydrogen. It was the same when we talked about moving electricians, electro technicians, and people in the oil and gas industry and mechanics into renewables, wind farms, solar panels. It'll take a period of time. These are the bottlenecks and the finance really stems back to the heart of it. It's this underpinning in insurance and the risk associated with that. Investors tend to be risk averse. The issue then is electrolyzer capacity. This figure is from 2004. Our 2024, it's 1.5 gigawatts, and we need to be at 230 gigawatts by 2030, which is a significant hurdle in this hydrogen transition. I hate calling it the hydrogen highway because we've had a few people use that over the last 3 or 4 decades and it went nowhere. So if we look at certifications, schemes and case studies, because really it's about case studies, the European Union certified high, green is less than 3.4, low carbon is less than 4.4. Really, the challenge here is RED 3, the harmonising of the standards in the EU taxonomy and agreeing. It's a bit of a horse trade between different member states, different interested bodies. The country that tends to have the biggest say in hydrogen is Germany. Germany, if you look at patents globally, there's 3 leaders in hydrogen patents, and they are Germany, Japan, the USA. After that, then we have France, China, Korea, and then we would have the UK and France. So they would hold the patents and they would put a lot of pressure then on the EU in terms of what they want. Because if they have the patents, they want to develop their own technologies, and industry will put them under pressure. So the United States, we have the IRA, which is the Inflation Reduction Act. The problem here is that at the moment, the US economy is having a bit of a wobble. The Trump's tariffs aren't helping the renewable market in general. They're not helping. They're not helping global economic stability, and thus I think every sector is coming under pressure, including the automobile industry, the pharmaceutical sector, and the ICT sector. And we can see it even with chips. All sectors are being weaponized in terms of the strength of the dollar, what's happening, the geopolitical issues around the world. And I think what's happening in the Middle East in terms of Palestine, Israel, and we've seen Sudan recently escalate even further. It is putting global markets under huge pressure. I suppose the center of this regulatory harmonization is safety. So people use safety matters as an excuse to push back. So if we look at renewable energy, ICT, big data, AI and the ICT sector in moving into the energy sector, how the energy sector, and I take electricity and the power industry as an example, it pushes back using a number of things, including safety, regulatory frameworks, GDPR and data. In terms of the hydrogen safety and regulatory hierarchy, it's easier to work with it because it fits within the petrochemical industry and the oil and gas industry. And those sectors tend to have to work with each other because it's a global supply chain. The electricity and the power industry is very state-centered, very regional, very anti-competitive, and tends to have a mechanism to push back on AI and the efficiencies that can be gained there for these reasons. And we'd have, even though we have very large market participants in the hydrogen space, companies coming from the oil and gas industry, we have likewise in the electricity sector, very big former semi-states that have a state connection. The ICT sector, and if we take the likes of the Googles, because they are interested in hydrogen as well for their data centers. We take the likes of Amazon, Microsoft. They're very unregulated, very wild in what they do. And they find it very, very difficult to navigate the energy sector and decarbonisation as a general rule of thumb. And what they tend to do to reach their green goals is work within the framework of ESG, environmental social governance. And I suppose then we hit the phrases of greenwashing, green elbowing, green whispering, sort of making things look green. And in the oil and gas sector, you know, you can make hydrogen production in certain ways look green, even if the numbers don't stack up. And that's why it's very important that we have the standardization, we have the regulatory framework and that robust certification, but caveated with a harmonization period over a number of years. So the next aspect of the policy framework and the transition will be the environmental and social dimension. People who are anti-hydrogen, and we can see it with the Whitby, and we can see it now with the repowering of onshore wind, with our need for increased overhead power lines in rural areas to meet our targets, our renewable energy targets. We can see that environmental issues come to the fore, but we also have an element of NIMBYism, so not in my backyard, people's reluctance to embrace new technology, whether it's right or wrong. What tends to happen is technologies take off over a number of years and we learn as we go. We make mistakes, For example, wind turbines, some of the earlier wind farms, if you look at the environmental impact statements, there was no recycling of the turbine blades written in to the planning permission, the planning consent. So if you go to some parts of the world, it's the same with solar farms. You'll see abandoned wind turbine blades at a wind farm. So they've replaced a wind turbine, but they've left the older turbine blades behind because actually they're quite difficult because they're a composite material to get rid of. The same with solar panels. And this will become an issue into the future with rooftop solar as well. Obviously, with hydrogen, we're going to be in a situation where we have the existing natural gas network, which we're going to have to integrate in some shape or form. I think to build a parallel hydrogen network, full bells and whistles from the get-go will be problematic. I think a backbone to the major industrial needs first to maintain employment, economic viability and critical mass in terms of demand and offtake is very, very important. So if we go, the issues people will quote is high water usage, okay, land use in terms of renewable infrastructure pressures already existent, air quality, fugitive hydrogen emissions, which you have the same with fugitive hydrogen or methane or natural gas emissions from the existing gas network. That in itself is an interesting statement because if you look globally, there's not a lot of research has been done on fugitive methane emissions from natural gas networks. From the research I've read and the data that's available, figures of 3 to 6% are bandied about globally, but it depends on the quality of the natural gas infrastructure and its age, like anything else. So the next part of that puzzle is the social life cycle analysis. So it's moving people from one sector into another. So if we look at local government, we'll take it as an example, that social problem. When we let engineers and technical staff go from local authorities, from say the roads department back in the 80s and 90s, and we outsourced a lot of the design work, similar now will start to happen in a lot of the energy companies. It happened already in the telecom companies. So if we go back to British Telecom, we go back in my country where I'm from in Ireland, we had Aircom. And what tends to happen is a lot of the people who would have been involved in overhead line design, wood pole design, tower design, foundation design, transmission pipeline design, distribution pipeline design have been laid off or let go or made redundant, and those skills haven't been transferred. So the labour rights of new staff coming in and how we move from methane, okay, natural gas and that energy sector in general to a hydrogen backbone and network and train up those skills. My own personal opinion is that companies, consultancy companies, we take the likes of Arab, Jacobs, RPS. My own personal opinion is PM, Mercury Engineering, any of the big engineering companies around the world. I don't think they have the skill set or the volume of staff unless they do a lot of copy, paste, repeat of design standards. I don't think they have the number of engineers to do what we need to do across all sectors. If we relate that back to the third sector or the third level education sector, our job as academics is to train and teach the fundamentals. And when I was an engineer and I worked as a graduate engineer, I was trained in how to do technical design work by my boss. During the noughties and during the late 90s and the 10s, a lot of those staff who would have trained me retire. So there's a significant skills gap around the world. So we can call that labour rights. Equity then is, where do we import people from around the world? So there's a brain drain from certain parts of the world where we're importing engineers from Africa and Asia to Europe and North America, and from South America to North America. What happens then in those countries? That is a form of green colonialism, and that in itself has its own concerns. The other issue we need to be very, very careful of is giving the right message or the wrong message to the public at large. So we've seen it with transport electrification. If we say we're going to achieve 20% EVs by 2020 and we do not achieve it, it's embarrassing for politicians. It's embarrassing for people in local government and national government and devolved governments. You know, people may say in the back of their head, well, it won't bother me as a professional, I'll be gone. But actually for young people coming up, they become despondent about renewable energy, about sustainability, sustainable development goals at large. And then we reverse back into, you know, unsustainable practices. So it's really, really important that we take into account the realism of what we can do. And I think it's really, really important that we as academics, engineers, researchers, scientists, social scientists, economists, caveat everything we say for the public. It needs to be warts and all. It needs to be an honest conversation. So I've picked this hydrogen governance in terms of the hydrogen infrastructure map and the hydrogen backbone. The UK, even though we've had Brexit, we're not part of the EU anymore. In terms of energy, we really are. So we have the EU Commission, we have the Department of Energy, we've our BES now, DESNES, and then we have all the various standards organisation. There are groups and bodies that meet, but are they coming together fast enough? And I relate this to something that happened over the summer in Spain, which was the massive grid collapse, the power outage in Spain and Portugal. In the UK and Ireland and in Denmark, we're very, very familiar with large amounts of renewables coming onto the power system in different areas really, really quickly. And we manage it very well because we've created ancillary services and fast frequency response services. Not all countries in the EU are as well versed as we are in this. And in the case of Spain, it was very, very clear that there was a disjoint between the market, the grid operators, the generators, and a mechanism for somebody to basically pick up the phone and say, because you could see this event happening, there was too much solar coming on really, really quickly. It was calling frequency events, and they were unable to manage it fast enough in real time. And now the EU has created a group or a commission to investigate it, which is a mechanism within the EU framework. If we look at hydrogen and we look at what happened with electricity, because electricity is normally ahead of the curve when it comes to these things, we were asleep or they were asleep at the wheel. And I would suspect it's the same now in Italy. It's the same in Greece. It's not as bad in Germany and France, but we need to have some sort of mechanism that if something happens very, very quickly in real time and we can see it happening, all market mechanisms are overridden and the national grid operator can instigate a very fast emergency response. And in terms of hydrogen, we need to be very well versed in terms of resilience, in terms of emergency events, if we are going to build a hydrogen backbone. So this mutual recognition and harmonization really is at the heart of everything we do. So if we look at the COP28 declaration, they want that hydrogen, that international hydrogen certification. We need to standardize more the life cycle assessment of the hydrogen supply chain. But it's never going to be fully perfect, and we need to recognize that also. And within that, there needs to be mechanisms, or as we would call it in engineering, a boundary condition or a level of error, okay? A window for us to sort of work in that allows us to have a frame that we can move in and out of for global harmonization. It's going to take 5 to 10 years or longer. So I think that we need to sort of trench in, not over promise, and be pragmatic to gain the respect of the public at large and to get buy-in, not to make any mistakes, and not to be in a situation, and I'll take Spain and Portugal again, where people who are anti-renewables, anti-oil and gas, because we do have the two opposite ends of that that argument, you know. I'm centric. I think we need all energy types. I don't think one shoe will fit all. We're going to have different shoes, different socks, different colors, depending on where you are in the world, and different jurisdictions, different regions are going to take longer to join that story. And we have to respect that. So this lovely graphic created by Dilzar and the team shows how long it's going to take. The challenge really is balancing the regional realities and global consistency. We don't want to be like the carbon certification market, where it's actually not credible, where if you look at the price of carbon per ton, it can vary from like $1 to $150. You know, that actually defies belief. For something to be worth such a variance would undermine any market for any investor. So you can see here that balancing the ambition and the feasibility, the threshold requirements, if you look at it, really depends on the regional electricity carbon intensity. So what's going on already in your country feeds into it. So that's a key restraint. And we can change that for 20, 30 years, 40 years. I'll give you an example. There are some countries in Asia, okay, that actually only bought new coal plant 5 years ago, and they're locked into contracts, turnkey contracts, with a PPA, a private power purchase arrangement, for maybe 20, 30 years. They're stuck. That's it. So they're going to be slower to the hydrogen party than others. But maybe that's a good thing, because then they don't have to invest the time and effort in writing hydrogen standards, regulations, training people. We'll have done it and can help them transition. So that's about, I suppose, tiered targets, capacity building, and then us transferring our technology and our knowledge globally. So that in itself is a business opportunity. So what we're proposing from Hyatt, the group, and my colleagues who authored the paper, particularly Dilzar, who led the challenge, is standardize the greenhouse gas emissions quantification methods, adopt mutual recognition agreements, and that's already been, I suppose it was mentioned. We wrote the paper actually over the last 2 years, but in COP28, it came to the fore at one of the meetings. Integrate broader sustainability criteria in terms of land, water, and the social dimension. And I draw a parallel here now to data centres. Myself and Dilzar do a lot of work on data centres, and we're talking to David Flynn and Sarah about that at the moment. And again, it varies by country, okay? So some countries, land intensive for data centres, it doesn't matter, it's not a challenge for them, but in some more populated, densely areas, land can be a challenge. Water, which is a big draw as well for data centres, that can be an issue in many countries. And moving forward, it will become more of an issue for data centres. So changes in their technologies in terms of DAC, which is direct air cooling, in terms of immersive cooling technologies, that will all take time. But the problem for the data center sector is similar to the hydrogen sector. It's that capex. So when an investor or one of the big companies is looking at investing in a new data center, they want their payback on that data center in terms of its return of investment. They want that back after 5 to 7 years. So that capex has to be paid back. But if you want to shift to newer technologies like immersive cooling, like DAC, you're talking 7 to 10 years. And that in of itself, even though those companies are very wealthy, they have very fickle investors. And the last thing they want to be doing is, dropping 2 or 3 points on the New York Stock Exchange. It throws everybody into a panic. So mutual adoption and recognition, integrating broader sustainability criteria is for a reason, because it feeds into ESG, which feeds into then investor and stock market decisions and the value of a share. So what do we do then in terms of certification? Do we leverage AI and blockchain? There's a pro and a con for the blockchain in terms of the energy consumption. In terms of AI, there's pushback because of the data, the big data, that territorial aspect in terms of the European Union versus the USA and Trump. So data is being used as a weapon, okay? And then us protecting our data from China. And that's just part of the way it is. And this is why we do it. So that EU Data Protection Directive from 1995, it started back then. It came into effect in 2004, 2005. And the delay in, say, using AI across multiple sectors like pharmaceuticals, rail, things like your Oyster card, it's so small things that it affects. Electricity and smart metering in the home, all of these small things actually are part of this bigger, sustainability transition. And how do we integrate smarter tools? Because actually we don't have the manpower to do all this work. We actually don't have the brain power of humans to do it all in real time. So it's going to be a slow process. It's going to be a windy road. Eventually we're going to get there. Now I'm 52. This is 2025. I'll be 62 in 2035. And I hope I won't be giving this presentation again. I hope actually I'll be saying, actually, it's great to see what we discussed being achieved. And I'm now going to go back to a sector that I worked in the 90s, which was the mobile phone telephony sector. I remember I tested 3G mobile phones on the top of Grafton Street in Dublin. And I remember holding this concrete block, which was a mobile phone, in a backpack between my knees on the top of Grafton Street. And we were putting up a base station, testing and seeing would it work. And I have to say to people, look at where we've gone with mobile phone telephony. Copper is obsolete. Fiber is important, but we've really moved on in terms of we're at a 5G network. We're even gone beyond that now, and the amount of data that moves in those networks is just astronomical. So I think we need to be patient. And we will get there, but we're not talking about 2030, we're not talking about 2050. We've already seen that in sort of political discourse and debate. To me, really, it's 2070, okay? So if we go on to the next one here. So I think you can get from my narrative that I think it's really, really important we use modern AI and digital products and passports for low carbon fuels. I think it's really important. I think hydrogen digital twins, I think digital twinning is going to become really important into the future, because we do not have the engineers, computer scientists and scientists to literally sit in front of computers all day long, 24 hours a day, 365 days a year, to process the information. So it's really, really, I think, key to this is AI and data and hydrogen adoption. Now, there's probably some cynics in the room, and I'll get asked a question about it in a minute, but that's all part of the transition. So in terms of institutional architecture, that regulatory space, cross-sector, multi-level, is really, really important. And I'm just going to draw a parallel to the UK at the moment and where we're at. The delayed HAR rounds and the slow project development pipelines has given a lot of the gas companies, the energy companies, hydrogen developers headaches. Because what happens is, and I know from some of my former colleagues who worked with me in industry, they'll say to me, Aoife, oh, we're coming under pressure. You know, my chairman or my MD is asking me why that project isn't being rolled out. Why is there delays? And then you're lobbying Westminster, or you're lobbying Brussels, or you're lobbying different organisations, to even standards organisations, to get things pushed along. But I'm sorry, it may not happen in some of the people's lifetimes who are in their 60s now. So we just have to be patient. Clear signals are important, but at the heart of it, harmonisation is key, and that harmonisation needs to allow us a little bit of wiggle room, because if we have that wiggle room, it mitigates the underwriting risk. It then mitigates investor confidence. It actually bolsters investor confidence, and then it lends to investment. At the moment, what we have is we just have people being a bit cynical about where we're going. I think we need to sort of just stop being cynical. Now, I have days of cynicism as well, and I have to say to myself, Aoife, stop. And then I think about mobile phone telephony, and I think of where we've gone. Okay. So finally, a key challenge in terms of governance for our exchequer and our states is this tax take. So as we transition from a heavily gas-dependent environment, natural gas-dependent environment, to more renewables, more mixed natural gas networks. So they're going to, there's going to be biomethane. There's going to be some element of hydrogen. You're going to have some element of a hydrogen network as well. Hydrogen will be in industry first. Then I think it will be in heavy transport. Then I think it will start to proliferate. It'll be in storage for renewable integration. And we'll see where it goes from there. But I have to say that some of the energy market, and I mean the off-gem type markets, are giving us headaches. So what do I mean by that? So if we look at renewables and we look at wind generation, they're quite happy with the status quo and the way things are, because it means that they get paid to generate at the natural gas price. And a lot of those companies now have invested in battery generation. And that means now that when they're not generating, they have the battery that makes them more money. So there's a bit of an imbalance and a bit of a challenge between, where do we set that strike price in terms of energy? Now, I'm not using electricity anymore, because my opinion is that we base everything on electricity. We should have an energy market where we integrate transport, heating, cooling, and electricity in an energy where we have kilowatt hours in terms of consumption across all of those, and they're transferable. And I think that would lend itself to a better market. The challenge for the Exchequer and the Treasury in this case in the UK is it's that point where we have a crossover between a renewable, sustainable energy kilowatt hour with an element of fossil fuels in it from that fossil fuel tax take. And I don't think they're doing their job well enough or good enough into the future for us to be able to predict what's going to happen. And that's a huge sovereign risk for any government to make. And I think that's a problem. Then that leads into energy security for a sovereign state. We saw what happened with the Ukrainian crisis at the start when gas prices went up very, very rapidly. And that leads then to price stability issues. And then that leads to social issues with elderly people, energy, that just transition framework. So this really is really, really important, and we need to get this right. And I think, you know, we can blame Ofgem, or people can blame Ofgem, or different groupings can blame Ofgem, but to me, actually, Treasury needs to do more. I think there needs to be more from the Treasury in terms of this. It's really, really important. And I think that's something where us as academics and leaders in our field, guiding industry and policymakers, we need to step up as well. The economics really, really are important for this. So my summary slide is, you know, the road ahead. We need to go from a fragmented situation to a alignment of standards and certifications and cross-border trade. We need to do that where we harmonise and have a transition period where we mutually agree to appreciate that we're all starting from a different standpoint. We need to consider the social and environmental metrics that feed into ESG, that then feed into investor decisions. The reason why that's important is because when a developer is borrowing for his CapEx, he needs to get a good interest rate that makes the project fly. And some of those line items in his cash flow will be elements like a tax credit, the HAR, you know, what he's going to get paid for the offtake, or she's going to get paid, sorry. So digitization is very, very important too, because we do not have all the technical staff. International coordination and collaboration is key. That'll give the market confidence. It'll free up capital, and it will lead to carbon reduction. So thank you very much. So these are the key messages. I think the EU, the UK, the USA, and Asia are the heart of that. On a closing point, I'd just like to mention that last December I went to the COP, or it wasn't the COP, it was the RD7 for the G9 nations, or one of the Gs in Delhi in India. And I met colleagues from Japan, Brazil, South Africa, India, China, Korea, Mexico, the USA, France, Germany. Then there was Europe, and I was part of the UK team. And I have to say that it was very, very difficult to get consensus on some elements. You could see the political machinations and the sovereign state protectionism. When we were there, Trump had been elected, and it was clear that the Americans were in a hard place. And actually, I emailed them subsequently about a few matters, and I got no response for a few weeks. And then I was told some of them had been let go from the organisation. They were made redundant from the organisation they worked in. They arrived into work one day and they were told to go home. The French were slow to respond. The French were there as well. And what I felt from France is still a very big nuclear country, and I think France's vision for the future will still be nuclear. And I think the bailing out of the French EDF made that even more clearer. And I think Uniper in Germany is a key challenge as well. So there was a German rep, and then there was a EU rep. But they were both Germans, which was interesting. And I think moving forward, this harmonisation will be key. And I think there is a recognition of that now. It's just like transport electrification. So that's basically it. Thank you very much. Has anybody any questions?
There are 3 questions in the chat. If we can get to those, and then any that we don't have time for, we can arrange to answer those via email. Can you see the chat there, Aoife?
Just 2 seconds now. I just open it up. Okay. I can't see the messages because I'm not a member of the chat.
Ah, right, okay. So I'll go to the first question, which is what happens when policy ambition and funding outpace regulatory design, as seen with the EU's delayed RFNBO Act or the UK's unclear CFD integration for low carbon hydrogen?
Okay. So I suppose the key thing to that is market stall. So if we look at like first wind farm development for a period of time, we had refit. So we had FITs, which are basically renewable obligation certification, feed-in tariffs. When they were available, the market flourished because it meant that you had a line in your cash flow for your when you went to your investor, your bank, basically to get money, when you were a developer. So if we look at, and it's the same now for any of the energy companies, they have to go to their investors and banks to borrow money. And if policy and regulatory frameworks don't match and there's a delay, what happens is the market stall because they can't leverage a low interest rate. And a high interest rate means for a more expensive project with a longer payback period and a lower return on investment, which means more risk, which means then that these entities, so in the case of large energy companies, they will look for more money from the government. So that's the challenge. And we can see that in the EU with the renewable fuels of non-biological origin, that's been delayed, and the slow integration of hydrogen into the existing CFD framework, and the HAR, that's led to issues and challenges with investment.
Thank you, Aoife. Right, I think we've got time for one more question. This is from Melinda Adoni. There have been significant withdrawals of investors from hydrogen projects recently in the UK and on an EU level, despite these projects getting subsided and funding. In the UK, there have been CFDs agreed around or more than 200 MWH. Why is this happening? Are we getting the subsidising part wrong, the standards? How can we increase the profitability and attractiveness of green hydrogen?
Okay, so in terms of green hydrogen, I suppose it's a global issue in that, first of all, some of the technologies in these, so they would have a life cycle. They'd say some of these planter, they're going to get this electrolyzer by year X and it's going to perform in a certain way. So that's underwritten, and that's part of the guarantee in the contract. Okay, so if it's a turnkey contract. So some of the suppliers, the OEMs, can't supply when they said they'd promise. So I give you an example. For a wind farm at the moment, if you want to develop maybe a 200 megawatt wind farm, yeah, I'm picking 200 megawatts or 100 megawatts because there's some of the scales that I have worked on are 50 megawatts. To get a transformer for a site like that, you have to pay up front 5 million. And a lot of these companies would not have that cash, or these developers wouldn't have the cash to actually put it up front. So they're speculative investors. So even though lots of projects exist, they're actually almost like ghost projects because they're highly speculative. And then in the global market, an investor will see that, they will do a due diligence and they will look at all aspects of the project in terms of the government subsidies, the CFD scheme, the global market, the supply chain, the offtake, the environmental planning, permission and consents, the regulatory framework. And if the numbers don't stack up and who they send it to is somebody like me. So every now and again, I get a call from like a bank and they'll say to me or an investor, Aoife, can you have a look at this project? And that's what I did for a number of years, that due diligence. And if it doesn't stack up and the numbers don't seem right, then I assign a risk to it, and that risk goes back to the investor. So that's what's happening. The other issue is what's going to happen as will this Ukrainian-Russian situation taper off? Has Trump choked China? And is the Chinese economy declining? Maybe even though Russia now is building a pipe network to export its natural gas to China, more of it, they will not be willing to pay, that China won't pay the same price that the EU paid for the natural gas. So will that lower natural gas prices? So does, like, how do you hedge? How does an investor look at that? So they're the sort of challenges to that. I hope I've answered your question.
Thanks, Aoife.
Merlinda.
Thank you.
That's great. Thank you so much. Aoife, we do have a couple more questions, but I'll send them to you via email if that's okay, with everybody's
Okay,
contact
could you put in
details.
the name of the person with the email,
Absolutely.
Sophia?
Absolutely, no problem at all. I'll make sure I do that. Hi, Melinda. Thank you so much for your question. Just seeing you put your camera on there. Well, thank you everybody for attending, and thank you so much for a brilliant presentation, Aoife. We'll be uploading this to YouTube in the next few days. So if anybody wants to have a look at it again, it has been recorded and will be popped onto there. Thank you so much to everybody.
Bye, guys. Have a lovely day.